right, just going to restart the Unity Learn Create with Code module from the start, running through it. I'm not going to even use the new input system that Unity has. I'm just going to go run through it the way it is displayed online, just so that way everything is succinct and should be pretty easy. I already have done it to a certain degree. But I just want to have everything kind of like documented going forward. So I'm just going to restart from scratch. Not all the way from scratch. I actually worked on it a little bit this morning, but then decided that I would stream it to document it. So we're just going to run through the whole thing. Shouldn't be too hard. I'm going to try to do all the challenges for the most part, grabbing at least like what I find valuable to my kind of journey here, but will be, um, like kind of skipping things if it's like too much of a pain in the ass to do. Now, I will eventually do everything, but I would like to kind of just, speed run what's important to me so I could at least get to creating original content on Unity. Um, you know, sooner than later. But like all I know module what is it? I know lab 2 is unit 2 is really
Now
good,
watch
so
and
I'll
pay
be
attention
spending
before
a
you do
bunch of
this
time
yourself.
on the
We have our layout
um unit 2 stuff. So let's go ahead and
set up nicely here in Unity, so
get
everything
going.
is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window and then make sure you right click on the assets folder. And then you're going to go to the create button and we're going to create a new folder. We're going to name this folder scripts because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library,
Hey.
or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder, so we right click over our scripts folder and we create a C# script. Now we're going to name this script player controller, capital P, player, capital C, no spaces, controller. Now, when we press enter, Unity will automatically create this script for us and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C and why are there no spaces? Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right click on it and I click create C# script, and I don't know what to name this script for now, so I'm just going to call it test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention so that way it's easier if other people have to jump into your projects. So I'm going to just right click on obstacle fly and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector, and so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left-clicking and dragging onto our inspector if the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this gear icon next to it, and we can actually remove that component. Or if I wanted to add a component another way, I could also click the Add Component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name, so we have that player controller, added it there, but we don't want it on our obstacle at all, so we're just going to click on the gear, remove that specific component, and we're good to go. So what you're going to do is you're going to right-click. We've created a scripts folder, and we've created our first C# script, and we've applied it to our vehicle as a component. And now we're actually
What
going
I'm going
to
to do
get
is just
familiar
watch
with
all the
our
videos
script and the
through on
structure of it
this
before we write
1.25
any of our
speed
code
just
inside of it.
because it's
So make sure that in your
easiest to
assets folder you
understand
have it
and
expanded,
actually hear.
and then you open up your scripts folder by expanding it.
And
And then if you
I've
double click
already done
on the
most of
player
this, so I'll
controller
probably
script,
just go ahead and
now you can see that my script has
like
opened up
speed
in
through
my
actual work,
IDE,
but
which stands for an
we'll leave it like
Integrated
that.
Development
Just
Environment.
because I want to
And
have this all
basically, an
documented.
IDE enables us to actually interact with our code and write lines of code and
Is this
text
my
inside of
shit?
it. So
Oh,
you can
it
actually
is.
see there's
Okay.
words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write a essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger. It's just a little hard to see. So on the bottom left, I have this little zoom option. So I'll set this to 200. It's pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use some different colors for words because it helps make it easier for me to see. So you can change those settings on your own, or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you will download Visual Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand. With our script itself, our player controller, you can see the name that we made before. And in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called MonoBehavior. And MonoBehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from MonoBehavior. And that's very helpful because in MonoBehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement, and here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call the start method. Versus the update method, another method from MonoBehavior, and update is called once per frame. So this is actually constantly checking in your game for different calculations it should make, or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here, you can see, so these two forward slash marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the
I set
purpose
this
of a
up
person
pretty
to
goddamn
understand
fire. I
what
forgot
they're
how
reading
well I set this up
inside of
before I just
a method.
stopped using this.
Versus the methods are
Definitely
actually
gonna
the
just
pieces
continue
of
to use
information that your
Slime Lord.
computer
I'm not
needs
making a new
to
account
run certain
for
tasks. So now, in our update method, we're going to write our very own comment. So make sure that
bullshit.
you have your text selection inside of the
I'm
update
just gonna
method.
just start streaming us playing
And then
fucking
if you write
Overwatch also.
/ two forward slash marks, we can say we'll move the vehicle forward. And so now this is where we're going to write our line of
How,
code
how
to
is
move
this
the vehicle forward.
comment,
But for
Jay?
now,
What if
we're just going to
like
make a note for
someone
ourselves that
like
this is where
wrote
we're
this
going to do
kind
it.
of a comment? Like, is this like a
So what
valid
you're going to
comment?
do is you're going to double click on your player
That was a
controller
whole
script,
video for just a
and
comment,
then
bro.
your player controller script should open in the Integrated Development
We'll move the
Environment, or
vehicle
IDE,
forward.
that was set by Unity. And then in your player controller script, down in this section of code here, right after public class player controller, you can see all of the different methods that are automatically added by Unity. And specifically in our update method, we'll write a comment using two forward.
All right, so that was 7 minutes of video for legitimately, okay, open the C# script. Yeah, I know. I even said it like right at the beginning. I don't know if you were here right when I turned this on, but I said like I'm going to like I want to document everything. Like I know it's slow, but I've actually already done this module, but like I want to go from step 1 all the way through. Also, I might just pick up some like BS that I left behind in my brain just because it was fat. Like I kind of ran through it fast last time, so I was like, you know what? For the documentation, I'm just going to run through every single, just all of it. Like I'm just gonna go run through everything and not really skip. How the fuck do you spell vehicle? Yeah, we'll just yeah. I believe I already know how to do this, but I will wait. This is gonna be a transform.translate, and then vector3 move forward. I believe all we're doing right now is just pushing the vehicle in a straight line, so dumb easy. But why is okay? I guess that's it. My game view. Honestly, Unity straight fire. I was looking online. I don't know if you're here, but I was looking online. They're like, Unity's probably the best way to start, but even if you're going to start with Unity, like eventually learn Unreal Engine as well. Like if you get both Unity and Unreal Engine, you'll basically be able to create projects and a portfolio that'll actually get you a job. So Unity alone will probably get you a job, but if you know Unity and Unreal Engine, you just get paid more money. So hopefully, it all pans out. All right, let's go ahead and give the vehicle forward movement. So it's gonna be dumb slow. But at least this
We've
will
opened up our player controller
keep
script,
me.
and so now we can see all of this code that's inside of this script. And so we'll actually write
I,
our
I feel
own
like
line of
just
code
having the
so that we
documentation
can
will
make
help
the
me even
vehicle
in
move
my brain,
forward
just like actually
from our little note we made for
keep it
ourselves before. Make sure you pay attention
all
before
together.
you do this. So what we're going to do is we're going to
But
write
this is
our
gonna be
very
boring as
first
shit.
line of code here in our update method. So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're going to do is we're going to program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application or if you're going to make a website, there are other languages that you can use to create those different kinds of applications, but for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand. to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector on the right side, as I'm moving this blue arrow in our transform component, you can see that the Z is actually updating. And so that gives us a really good hint of what we're trying to accomplish. So if you remember, our transform component was the thing that was updating as we moved that vehicle in the scene. In fact, we can actually use the transform component directly. So if I just type in transform, and in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class that has even more methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicle's transform, what we actually want to do is we want to move that vehicle in that z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. And so you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does, it is actually suggests different things that I can do and can autocomplete certain statements that I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector3 translation. So this is a parameter. This is a piece of information that I tell the computer to use to be able to do the thing that I want it to do. Now, I don't necessarily know what a vector3 is right now. So let's see if there's other options. You can see there's 6 total options. And this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is I don't want my vehicle to move in the X direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction. So I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon. And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we wanted to happen.
Save.
Let's see. Get out of play mode. What did I do wrong? So let me just player controller. Oh, I forgot to save. So you can see in our project window, I selected our player controller
forgot to
script, and
save.
it looks exactly like how we left it when we first opened it. There's no information inside of it.
What's cool about this
But
is
as
I'll
you
be
can
able
see
to
in our
like
script here,
document the
we've
time
added
as well.
2 lines in here. We've added
This
a
man
comment and
talking
we've
slow as
added
hell.
this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes, speeding all the way off the runway. And it's flying off into space. Maybe it is a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're going to do
is do it in 5 seconds. This guy says that you're playing Halo, dude? Playing Halo Infinite? Bro, I was playing it like not too long ago. Oh, what the fuck happened here? Transform.translate. Did I seriously fuck this up? Oh, wait, no, it is in the update method. How come this didn't work? I saved. I know for a fact I saved. Oh, you know what? I never freaking put it on the vehicle. That's what it is. Put it on blue car. And then also rename this to player. And bam! She's gonna be flying. There it goes. Yeah, see, like, I don't understand why Halo didn't. I don't know. Like they didn't have to drop it with Forge, so they could have been like, "Hey, we're dropping it," but like they definitely should have had that on deck. Like to drop it like year or so later is definitely just foul.
Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So, with our player controller script
Yeah,
open
that's
in our
sus.
IDE, my IDE does some really useful things to make my life a lot easier. So, one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying.
Yeah, that game though, I'll tell you what, it does rip. Like I ain't gonna lie, there's a shit ton more tech in it, which kind of like, you know, it's good if I just don't have the time to learn all that tech, but aside from tech, it was like Modern Warfare 2019. Like it just feels really good to play.
Trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now, you might hear people say methods or functions in Unity and in C Sharp. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so, a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation or our dictionary tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate. And if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector3 translation. Now, in order to get a vector3, I can actually just type vector3. And here, now, you can actually see we actually have a suggestion as to what a vector3 is, which is super helpful. So my IDE tells me that a vector3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1
Yes. Yeah. Well, that's not how the brain works. You have to, it's repeat, repeat. What was that? I know. I know, you know.
all correlate to the
What was that? You talking smack over there? It's okay. Well, just come. You could continue to talk to me.
position
Uh,
on our transform component.
that
So
ain't
we have the
happening.
0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 001. So that actually, can save us a lot of time and especially
Oh
is very
shit, I
helpful
didn't
to
know
making
that
our
it.
code
Oh, that's
easier to
yeah. See,
understand.
this is what I
Because
was
if I
hoping
told
for,
a person to
J-Bone,
move
that
something 001, they'd be like, I don't know what you're
rewatching it,
talking about.
I'd pick
But if
up
I tell them to
some
move forward, they
small
know the
things.
direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand, in this case, the 001. So if we remove now our previous line of code, now we'll just make sure that we save. Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 001 to this vector3 forward. And when I
Oh
press
my god,
play,
dude.
our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 001 to vector3 dot forward. Now it's your turn.
All right. So I'm pretty sure this is gonna be like every video for the first bit, but this is actually what I forgot, I guess, translate that the vector 3 dot forward. This shorthand for writing this. I forgot. I didn't realize that it did like down to that level. I know it says get. Oh, okay. Forward. Is that all you wanted? What happens? I wonder if I write it twice. Yeah, I guess if I write it twice, I want to see something. I'm gonna code that. Oop, that's wrong language. It's SQL. Save. So this should obviously this will do the exact same thing that I was just doing before. But I want to see if I leave two versions of it, will it? Because this shouldn't error out. I wonder if it will go double as fast. Yes, it does. Interesting. Goodbye. The update, the update method, mad powerful. Okay. Next video.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame, but depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying. And for a computer, you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol. Because actually, if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening, who knows, we can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save, Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So cool, now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time.delta time times 20, comma 0 times time.delta time times 20 times 1 times time.delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20, so now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the Z value changing, and if you used a stopwatch, I'm sure you could see that it probably moves just about 20 times every second. So, now it's your turn.
Rippin'. Okay. So all he did, I believe, was this times time dot delta time times 20. Save.
Our vehicle now speeds along at a normal rate instead of incredibly fast or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our component system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body, which is a physics concept, and in this case allows us to interact with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier. We can use gravity or we cannot use gravity. So there's all of these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go, and with our obstacle selected in the inspector, we click Add Component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics, they both have mass, they both use gravity, so that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, you can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example, on our obstacle, if we turn off our mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make our little driving game simulation a bit more realistic, we're going to increase the masses of these two objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20 kilograms or so. And then the mass of our vehicles, I don't know, maybe something like 1,000. So now this has even more weight behind it, so when it hits that box, we see a slightly different effect happen. Yep, see? So took much longer for that crate to fly over the vehicle because it was much heavier. So, fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road. Using rigid bodies to be able to create physics on our objects, so that way our obstacle actually has weight, our vehicle has weight, and we're using gravity, so it's actually being pushed down into the ground at all times. So, what you're going to do is on your vehicle, you're going to select it.
We destroy all this shit. Okay. Video. Okay, so bottom.
We've got some physics in our scene now, and we've
So
got
delete
collisions
this
happening. So as our vehicle's driving the road, it runs into this box, box goes flying. And now we're going to make this road just a little bit more treacherous, make our game a bit more difficult for our player by adding some more
Yeah,
boxes.
this one I'm gonna
Make sure
speed the
you
fuck
pay
up
attention before you
because
do
I
this yourself.
believe all
Now what we're
he's
going to do
doing
is we're
is
actually going
making a
to
bunch
select the
more
obstacle, and I'm just going to make
obstacles.
this a little bit easier for myself. So I'm going to left click and drag the obstacle in our hierarchy and drag it all the way to the bottom of this list. So you see this little blue line underneath all of the other list of objects. And if we let go, now you can see our obstacles there. And now what I want to do is I need more boxes in this scene. So I'm going to select the obstacle in the hierarchy by clicking on it. And I'm actually just going to press the Control key and the D key at the same time. So if I Control D on our obstacle, it immediately duplicates our obstacle, and now we have another. And you can see if I hover my mouse over the scene and I press F to focus, it's directly on top of the other box. So that's not what we want. But we'll just move this one a little bit farther back. We'll try and get it to around 50 or so. I'm just going to estimate, yeah, around there is good. 50.1, almost at it. Now we have a second obstacle, but we want to add more. So if I just keep duplicating and dragging, that'll take a long time. So I can actually do something to make this a bit faster. So if I select my first obstacle and I Control click on my second obstacle, now if I Control D, it creates two more obstacles. And in fact, I can move these back even further, just about, let's call it like there. That's good. We'll shift my perspective, so I'll actually click the little green Y in our scene view. Now we have a top-down view. And now I'm going to zoom out, so we're going to Alt and we're going to right-click and drag it to the side all the way to the left, so we zoom out even more. And now we can see, maybe a hand tool might be useful for this. So I press Q, select my hand tool, there you go, so you can see more of the road now. Actually, it might help if I just turn. There you go. And then just zoom in a little bit. Perfect, cool. Now we can see our road even better. Really good opportunity to test out your movement skills and see if you can navigate your scene. So now we have our two boxes. Now we're going to make another set. So now I'll select my first obstacle. And in fact, if I just hover over the last obstacle, I press Shift and left click at the same time. Now all four are highlighted. Now if I Control D to duplicate, I have four more obstacles. Now if I select my move tool, I can move all four obstacles down the line.
This
Somewhere
guy's
like there.
just
Cool.
rolling
You can see this
around.
last obstacle, obstacle 7, is a little bit off the road, so we'll just delete that. So I'm just actually going to press the delete key on my keyboard, and it deletes it from the scene. So now we'll save really quick, and when I press play, you can see the vehicle drives, hits one of the boxes, 2, 3, 4, all the way down. You can see them tumbling down in the game view. So, up there the vehicle goes straight down. Oh no, can we catch it? No, it's gone forever. Well, we know the physics works now, so that's great. And we hit all the obstacles, and we've made even more, so we've made things just a bit more difficult. So what you're going to do is...
I already did that one. All right, well, that's lesson one. Let's go ahead and all right, I'm actually exhausted, so I'm going to stop doing this and I'm gonna play a game of League, then go to bed. So that'll be day one, and then tomorrow I'll um do the rest. I'll probably finish all of this tomorrow, and then the day after I'll finish all of the project two, and then I'm gonna actually start building my own game. I'm gonna try to by day three. I would like to at least like start building the maps and stuff, but we'll just kind of see how that goes. This weekend I plan on putting a bunch of time in, so we'll kind of take it from there.